Hello everyone and welcome to this video on the derivative rules for logarithmic functions. Let us start with a function f of x that is equal to the log base a of u, where a is a constant number and u is a function of x. So a is not any constant number because here you can only have positive numbers that are not 1 or 0. And u is also a function of x, where x is our variable of interest. Then the f prime of x, the derivative of this function, will be equal to 1 over what? 1 over u multiplied by ln of a, all of this multiplied by u prime. So if you want to evaluate the derivative of the log base a of u, the derivative of log base a of u, so all of this prime is equal to all of this, So that's it for the equation. Now let us look at an example. So if you have, let's say, 3 times log base 2 of x squared plus 3x plus 3. Let's just evaluate this. All of this prime. Well, then the constant number here, you can just take it out of the prime, so it will be 3 times log base 2 of x squared plus 3, all of this prime. So the constant number, you can just take it out of the prime, and then you can use your equation for log base a of u. Log base a of u is just equal to 3 times, because number 3 stays here, multiplied by 1 over what? 1 over u. The u is the function inside the log, so it's x squared plus 3 multiplied by ln of the base, which is 2. All of this multiplied by u prime, which is x squared plus 3, all of this prime. So your u is what's inside the log, a is the base of the log, and u is what's inside your log, and you have to take the prime of all this. So you will have 3 multiplied by, well, you will have exactly the same thing, so let's just copy paste that. Let's just copy paste that here. And you just have to evaluate the prime of x squared plus 3, which is only 2x. And then, since your number 3 here is over 1 and 2x is over 1, you can just multiply numerator together. You will have 6x over all of this. So your derivative will be 6x over x squared plus 3 multiplied by ln of 2. So that's how you find the derivative of a log function. There is also another equation for g of x that is equal to ln of u, where u is a function of x. We can use the same equation, exactly the same equation that we defined. So then g prime of x is equal to 1 over u multiplied by the what? Multiplied by the ln of the base, but here the base is e because it's a natural logarithm, so it's ln of e multiplied by u prime. But here, since it's ln of number e, all of this cancels out because it's just 1. The ln of e is just 1, so you will have 1 over u multiplied by u prime. So this is a new equation that you can also write like this. If you have the prime of ln of u, all of this prime, it is equal to 1 over u multiplied by u prime. So this is also another equation that you can use to evaluate the derivative of the precise problem where you have the natural logarithm. So example of this, if you have let's say 4 times ln of let's say 2x to the third, all of this prime, well, you can just take out the number 4 out of the prime, so you will have 4 multiplied by all of this ln of 2x cubed prime, and then you can use the equation that we just found. It's going to be 4 times 1 over u 2x to the third multiplied by 2x to the third prime, and then you just have to evaluate the derivative of 2x to the third. You can take out the 2 multiplied by the derivative of x cubed, which will be equal to 4 times 1 over 2x cubed multiplied by 6x squared. And then since this 4 is over 1, this 6x squared is over 1, you can all bring that together. You'll have 24x squared over 2x cubed, and you can also simplify this as 12 over 12 because you divide 24 by 2, and you cancel out the exponents, so you'll have 12 over x. So this is how you find the derivative of a logarithmic function. I hope you have fun finding your derivatives. Have fun and see you soon.